In the last video, we did a brief introduction of the 01 knapsack, and we talked about the two versions of 01 knapsacks, where in the first version, we can pick multiple copies. Why do I always say couples? We can pick multiple copies of each item, and in the second version, we only get to pick one copy of each item. In this example, just like in the example in the first video, we are going to be still looking at the example where we get to pick multiple copies of each item. If you do like these videos, please do subscribe. It's totally free. Subscribe, share, like, and comment. Okay, so for the 01 knapsack with multiple copies of an item, like we saw in the last video, the only criteria is we do not want the weight of selected items to exceed the knapsack capacity. And funny enough, we've talked about greedy algorithms. This knapsack problem is an example of a problem where greedy doesn't give the best solution, and that's why we use dynamic programming. So let's say we have a knapsack of capacity big W, and we have items, a lot of items. We have these items, many items. We have item 1, item 2, item 3, all the way to some item N. We want to take the item that returns the maximum value. In this version of the 01 knapsack problem, we are maximizing on value using weight as a boundary. So let's say we pick item 1. Supposing we decide to go with item 1, so it means that our knapsack, we have V1, that's the value for 1. This is what we have left if we pick item 1. We have this, that's the knapsack capacity minus the weight of, this is 1 actually, not I, weight 1. If we pick item 2, we have V2 plus this. If we pick item 3, we have this left, we have V3, then this left. So it continues that way. If we pick item N, we have Vn plus, so again, we've done our first selection, and after doing this first selection, we have picked either this or this or this or this or this. Okay, so we go again, just like in this first stage. I hope that you see the point already. This already looks like a tree, a recursive function of some sort. So all of this one, you have all options from items I, all of them, items 1 to item N again. You have item, so we go again for each of these. So if we pick item 1, this is an example. Now we'll have V1 plus this V1 we already have. So that will be 2V1 plus KW minus 2W1. So this is what our capacity would be. We have 2V1 because we have picked V1 twice, plus this is what's left. But supposing we pick item 2, we would have V1 plus V2 plus K knapsack capacity minus the 2 weights that we have picked. minus this, minus this. So this is how it goes up until we get to the, let's call it the leave expression, right? And we pick the expression that has the maximum value. We continue like this. By the time we are done generating the formulas for the weights at this level, each of these nodes, let's call them nodes now, at this level, will have, again, items 1 to n children. And for each of the children, we generate the formulas of what it would be if we had picked either of them. And by the time we are done, we get to the leave. The values at each leave would be what we have in consideration, and we pick the maximum value. I hope that this makes sense. So this is what we have. By the time we get to the leave, this is the maximum value of items with weights less than the knapsack capacity. So this, we want to choose the maximum. So we choose the maximum from I equals to this equals 1 to n of this v1 plus, in this case, let's, just for the sake of simplicity, let's say we stopped at this first level. For the sake of simplicity, let's say we stopped at this first level. So what I mean is, let's say this first level is our leave, right? So we want to find the maximum. We want to pick the maximum from each of this, from each of these Vn so this is what the knapsack is. Let's say base case, and we want to put all of this in an array, and that array is a table. In this case, it's going to be a 1D array. We want to, as we solve for this. This is how it goes. We solve for this. We have an array, right? Or a one-dimensional table. We have, so when we solve for each, we fill up the value. We solve, we fill up the value. We solve, we fill up the value. And by the time we are done, we want to choose the maximum value. So our AW is an array of values of weights of the items. So we could have something like, for example, we have 5, we have, just like that, we fill up this thing. So we can define as the maximum, the formula for the capacity of the knapsack with capacity W. So we define this as this of VI. We are generalizing now. So this is the formula for the 1D array. So let's pick an example that will make this clearer. Let's say we have, this is an example now. Let's say we have this weights 2, 3 that have values 5, 1. This is just an example, and a knapsack capacity is 10. So let's check out what our table would look like. So this is our table. So we are going to start the item at index 0. We want to look at, this is weights. So we have weight 0. There is no item with weight 0, so 0. So with 1, this is with I, so this is 0, this is 1. So with 1, we would also have 0 because there is no weight with capacity of 1. Okay, we also have 0. So for 2, here we are going to have 5 because we have, these are the values. This table is your table of values. So for the weight, we have an item with 2. It has capacity of 5. So how about with 3? Let's see. With 3, we have one item with 3 has value of 1. How about with 4? With 4, with 4, this is it. We have weight 2. We can pick it twice, and when we pick it twice, we have capacity of 10. So this is how you fill that table. How about with 5? Let's see. Yeah, when you add this 2, you have weight 5. So this is to this weight 1 plus weight 2. So we have value 6. How about weight 7? So this is how we go on and on and on and on. We do not want to exceed the capacity 10. So for 7, we could go 3 plus 3. Oh, that's 6. Oh, sorry. This is supposed to be 6. And this 7. And this 8. And this 9. And this 10. So for 6, we could go 3 plus 3, that's 6, but the value is 2. We could also go 2 plus 2 plus 2, that's 6, and the value is 15. So we choose that one. So we have, we did 3 times weight of the first item. So this is how we keep going and going and going until we fill up the table. I suggest you fill up the table on your own. We fill up this table, then we pick the maximum. This is it. We pick the maximum. I hope this makes sense. So the weights, let me put down this formula again. So this is simply from I equals 1 to n. You have value of this. So I hope this makes sense to you. This is the formula that produces this table, and at the end of the day, we want to pick the maximum. So this means that using dynamic programming, as we solve, we fill up this table. And at the end of the day, because we are looking for a max, our answer would be AW. That's in this case where knapsack is 10. So we would have A, where, supposing at the end of the day, our maximum is 30, right? If our maximum is 30, then this combination of the weights that give us value 30 would be our result. So we'll stop here. In the next video, we're going to shine more light on 01 knapsack. If you did like this video, please subscribe and like, comment, and I'll see you on the next one.